Good morning, everyone, or well, good afternoon. My name is Lynn Stevens. I am a PhD student at the Center for Computational Linguistics at the University of Leuven. And as you may have already guessed, my presentation will be about these funny little images called pictographs. So we work on systems that automatically translate text into pictographs and the other way around. We are currently doing this within the framework of a European project called Able to Include. And if you were here yesterday, then you might have already heard my colleagues from Thomas More talk about the Able to Include project, but just let me give you a quick recap. The project started in March 2014 and it's about to end in March 2017. And its goal is to improve the living conditions of people with intellectual disabilities. The idea is that natural language processing tools can actually bring independence to people with intellectual disabilities. For instance, they would really love to use social media websites such as Facebook or Twitter or email clients, but unfortunately these websites are not very accessible for users with reading or writing disabilities or difficulties. So our solution is something that we call the accessibility layer. It is basically a combination of three technologies that all have something to do with written language or dealing with written language. The first of all is a text and content simplifier. The second one is a text-to-speech functionality. And the final technology is the text-to-pictograph translation technology and the pictograph-to-text translation technology. And of course, in this presentation, I will only focus on the third technology because this is the one that we are currently developing at the Center for Computational Linguistics. So again, here you can see the accessibility layer. It consists of three language services, namely simplex, text-to-picto and picto-to-text, and text-to-speech. It will work in combination with applications such as Facebook or Twitter or email clients, so they become more accessible for the users. It is also important to notice that it is a context-aware and customizable accessibility layer, meaning that a parent or a coach can modify different settings to make it perfect or to make it suitable for the user who is working with this accessibility layer. So pictograph languages are a form of augmentative and alternative communication, and as you may already know, they are often used in schools or institutions or sheltered workshops as a way to communicate with users in an offline setting. Like you can see the images on the walls or in the schedules, the weekly schedules, or what's on the menu, for instance. Then you can see these little pictographs. Now, thanks to the recent technological advances, the use of pictographs in an online setting has been made possible. You can see a screenshot here of the Why Not website, and you are probably familiar with this website. It's a Flemish website that is very accessible for users with intellectual disabilities. Like it has easy-to-read news, it has text-to-speech, and it also has the pictograph translation system that we developed, because the idea actually came from Jan de Kelver. So he actually came up with this idea, and we made it a reality. So our system currently uses two types of pictograph sets. First of all, Sclera, secondly, beta pictographs. You can see there are some differences between both sets, and I should also mention that we can add more sets in the future, but these are two sets that are commonly used in Flanders, and they're also open access. That's also very important for us. Sclera pictographs, they are black and white mostly. Beta pictographs are colored, so the user can choose between these two sets at the moment. It's also important to note that the Sclera pictographs are more complex, so you would see more pictographs that reunite multiple concepts into just one pictograph, like to feed the dog. That's a verb, feed, and the object, the dog. So if you would translate text into Sclera, then the translation would probably be much shorter than the beta translation. In beta, you usually have one pictograph per concept. That's a small difference. Pictographs are very simplified languages. You can see that there is not really a distinction between singular or plural, or we do not have verb tense or inflection, so it's a very general language, and they have to be learned, of course, by the users. So first of all, the text-to-pictograph translation engine, which translates written text, Dutch, English, or Spanish written text into a sequence of Sclera or beta pictographs. We are creating this system to support written text, so we do not mean to replace written text. No, it's like some extra thing that makes it easier to read written text. And I would like to give you a very quick grasp of what the system does behind the screen. So imagine that the user receives a message written by another user, and it says, "I eat strawberries." I made the spelling mistake on purpose. Then first, what will happen is linguistic analysis. So the system will automatically analyze the input sentence. Then it will use a very big database of words called WordNet to find the meaning of each word. What is interesting about WordNet is that words are grouped together according to their meaning. So for instance, bunny and rabbit, they belong to the same, what we call synset, because they have the same meaning. Then the system will try to find the pictographs that are connected to these meanings or to these synsets, and these were established manually by my colleagues. What is fun about using WordNet is the fact that, imagine that there would be no pictograph for strawberry, no pictograph at all, then the system will know that, oh, strawberry is a type of fruit, so it can also choose to display a fruit pictograph instead of displaying nothing at all. The text-to-picto tool has a very language-independent design, so we have the same architecture for all three languages, and it can easily be extended to other languages as well. Like, for instance, last week we had the Russian students who managed to build a basic text-to-picto system for Russian in just a few days. That's because we use these WordNets. These are very easy to extend toward other languages, so we can actually make pictograph connections for other languages as well. Now, we've been working closely together with our partners, and they gave us a lot of feedback, and they did some tests with the users, and the users actually expressed their desires, their wishes, and they also pointed out some difficulties in the system. So based on this feedback, we are currently improving the text-to-pictograph translation engine. I would like to give you two simple examples. So first of all, the users noticed that if you have a very long input sentence, then it would correspond to a very long pictograph output sentence. And if you look at the sentence and its translation, that's really horrible. We cannot actually read this. It makes our heads explode. So we are currently working on automated syntactic simplification for pictograph translation. What does it mean? Well, for instance, we will split long input sentences into shorter sentences, or we will turn passive constructions into active constructions, so to make it easier to read the pictograph output sentence. So now you can see if we apply our new syntactic simplification module, then the sentence I showed you 2 slides ago will get translated into 2 separate sentences, which are hopefully much easier to read. So now it says, I visit baby Wednesday. So it's also subject, verb, object, a very logical order. And then I gave him, or I gave the baby, a bottle. So we also display the original text next to the pictographs. It's not on my slides, but in reality we do this. Also, we noticed that some users, they kind of know how to write messages, and that's a very good thing. Like they write their messages to their friends, and these messages actually contain a lot of spelling errors. And this has actually quite a lot of consequences, because if the receiver of the message, who also has an intellectual disability, for instance, tries to read the message, then it's very difficult to read. It's like a very phonetic way of writing things. You have to speak it out aloud to understand what is written there. And also, if the receiver needs to use the text-to-picto translation tool to read the message, then our tool, of course, will not be able to deal with the message because, well, like we say, garbage in, garbage out. It's very difficult for natural language processing tools to deal with wrong inputs. So we are currently working on a spelling correction tool for people with intellectual disabilities. We are using machine translation techniques for this. And just to give you an idea of why it is important to take the context into account, you can see the erroneously spelled word weekend in the dark gray box. So that's not a word in Dutch. It isn't. You can actually split the word into wie and kent, then it means who knows. Or it can be weekend without the final T, which is something like windmill sails. Or if you just pronounce the word weekend, you can already hear that maybe the user was trying to say weekend, like end of the week. So this is why it is very important to use these machine translation techniques to find the best translation of the erroneously spelled input sentence. Just a few words on picto-to-text, won't be so long. Picto-to-text translates a sequence of pictographs into Dutch, English, or Spanish written text, so that's, of course, the other way around. We are doing this for people with writing difficulties, so they can actually create a message by clicking on pictographs, or a combination of written text and pictographs for more difficult words. And just to give you an idea of how difficult this is, well, I told you at the beginning of my presentation, the pictograph languages are very simplified languages, so they do not contain a lot of information on number or tense or aspect, and you don't have pictographs for words like A or D. So this is a very challenging natural language generation problem, and we are trying to solve this also with machine translation techniques. Again, language-independent design, very easy to build a system for any language. It has the same architecture for English, Dutch, and Spanish, and we can make it for other languages as well. Just a few words on how the user can actually create his pictograph messages. We are looking into different ways of making this easy for the user. So first of all, we are working in collaboration with Why Not on a static hierarchy of pictographs, which is basically a 3-level category system. If you click on animal, then you get types of animals like birds or fish. Then you click on the fish, and then you get types of fish. And also works with color codes to make it easier to navigate through the hierarchy. But of course, we still need to test this, and this is very important. So we do not know yet if this is the best approach. And we're also creating a dynamic predictor of pictographs, which can be compared to Google's autocomplete function for text, like you're typing something and it starts suggesting stuff. So imagine the user would write cat and dog, or well, select the pictographs cat and dog. Then the prediction tool can suggest things like to bark or to eat or to be. But this might not be a good solution for all users. So again, this is very important. We need to take customizability into account. The evaluation. So in the Able to Include project, as I've said before, we work closely together with our partners, and they are testing the natural language processing tools in different scenarios. For instance, mobility, like via Migo, or the Able chat, like they explained yesterday, or also the Facebook or Twitter applications in combination with the pictograph translation engine. And well, it's very important for me to learn more about what users want. So that's me together with some of the users at a daycare center in Belgium. And I had a really nice day, and they actually told us what went wrong, and I had a great idea of what was going wrong. So it was very important for me to be there with them. Finally, I would like to highlight the fact that the outcome of the pilot studies, the user studies, really affects our approach. Like, what will we do next? What will we improve next? To give you some examples, the spelling correction tool, we made that one because our partners and the users noticed that if you have bad input sentences, then the text-to-picto tool will be a complete mess. The output will be unreadable. So we needed to find a solution to deal with the bad input first before we start applying natural language processing tools. Also, the users said they wanted to see the original words written next to each pictograph in the translation. So not just a sentence and then a pictograph sequence. No, they wanted to see the pictographs with original words written under them. So that's why we created another version of the tool. The syntactic simplification methods, as I've said before, the sentences were too long and they were not easy to read, so we created these methods. And finally, we are constantly adding new pictographs to our database, new connections, new words, new concepts. We are in touch with the Sclera Pictograph designers, and they also add new pictographs for us on request. So we are continuously improving the tool by listening to what the users actually want to see. So, okay, thank you very much for your attention. If you have any really cool ideas for me, please let me know. Thank you.